What's up, guys? Today we're going to be looking at this integral here of x times e to the minus x squared from 1 to plus infinity. So let's start by dealing with the infinity here. We're just going to rewrite the integral, but instead of the infinity, we just put a constant a. And now we integrate as normal by doing a u sub, which we have taken from the power of the exponential here, and then we differentiate u with respect to x, which equals minus 2x, and then we bring the dx to the right side. So we get du equals minus 2x dx. And from this, we get minus a half du equals x dx. And we wanted it in the form of x dx because we can see that that is what we have in our original integral, so that we can put it in terms of u. So now we can replace x dx in terms of u, and we can replace minus x squared in terms of u, and we also need to replace the boundaries in terms of u. So let's do that next. So we get the integral in terms of u, the boundary a. You just simply put the x value a into this formula here. So the top boundary in terms of u is minus a squared. And the bottom boundary is minus 1 squared, which is just minus 1. Take note that the minus is outside of the squared, so it stays as a minus 1. And then replace the inside in terms of u. So we get e to the u times minus a half du, which gives us, by bringing the constant minus a half out, this integral, which is much easier than our original. So the next step would be to compute this. And let's do that now. So here we have our new integral, which, as you should know, the integral of e to the u is just e to the u. We still have our minus a half here, so e to the u, this integral becomes e to the u to the boundaries of minus a squared and minus 1, which is equal to minus a half brackets e to the minus a squared minus e to the minus 1. And now we have to take the limit of a to infinity. As a approaches plus infinity, minus a half times, I'm going to write these in fractional form. You get e to the a squared minus 1 over e. This is exactly the same as here, because it's a minus on both of these powers, so you can bring it down and make the power a positive. And as we can see that as a goes to infinity, e is a positive number. Remember, it's around 2.7. So any positive number to infinity is also infinity. But since it's 1 divided by it, we get 1 divided by infinity. And as you guys know, 1 divided by infinity is 0. So this term actually cancels out. So we don't get that. That's just a 0 right here. So we actually get, as the answer, it equals minus a half times minus 1 over e, which gives us 1 over 2e. So our original integral converges with a value of 1 over 2e. Thanks for watching, and I hope you learned something.